Good morning and welcome back to our tutorials. We are in the K-walls, which is subjected to tension forces. So for example, we are asked to determine the forces in every uh, member and then also determine for the height. Okay, so let us get the slope here. Actually, this slope is 1.5 and 2. But we can simplify it further. Let us say you have this one 1.5, if you multiply by 2, that becomes 3. And this is actually 2, multiply by 2, this becomes 4. And in other words, here is just 3 squared and then 4 squared is equal to square root of 25 or 5. That is why we have this 3, 4, 5. Okay, here we need to get the components. Horizontal components, take note you have CD. Just copy this vertical okay, or the slope 4 and then this hypotenuse which is 5. Now for the vertical component you have also CD. No, this should be 3 over 5 because this is horizontal. Okay, 3 over 5, and this is vertical component. You have CD 4 and then 5. Okay, take note that this is horizontal, we use 3. Okay, we use 3 over 5. Now if we sum up moment at A, we take like this: summation moment at A equals to 0, and allow our direction clockwise is positive, meaning if we move this one going here, that is counterclockwise, the distance of this one is from here is 5.5. So meaning you can have negative because it's counterclockwise, 4 and then 5, and then use this 5.5. Okay, this CD, which is horizontal, we move like this, it should also be negative. CD 3 over 5, and then the height or the distance is 2. How about this 3? This is clockwise, so it's positive, plus 3 times 2. This 8 going here, clockwise also. Distance is 2 and 2, which is 4, equals to 0. Simplify this one, negative CD. What is this? That is just 5.5 times 4 divide 5 is 4.4 CD. Whereas this one is minus 2 times 3 is 6 divide 5 is 1.2 CD. And whereas this is 6 plus 6 and plus 32 equals to 0. I can just add this one and make 8 because they are the same CD and CD, so that would make us negative 5.6 CD, okay, plus 38 equals to 0. So therefore I could say that 5.6 CD, if I'm going to move it to the right, or we can just write as well as like this. We divide both sides by 5.6, then CD is equal to 6.79 kilonewton. Okay, next is we move to this joint. Consider this joint. We consider this joint C. Okay, and we have this one. Okay, we move this one. It's already given the 6.79. What we need to do is just to sum up forces, vertical and horizontal. So if I sum up forces horizontal, summation forces horizontal equals to 0, all going in this direction as, let us say, positive. So you have here 6.79. Take note that this is horizontal, so we're going to use this 3 all over this 5. Okay, and then this is going here negative minus this is BC. What function is this one? This is adjacent to angle, so this is cosine theta equals to 0. Now if we sum of forces horizontal, okay, but wait, let us simplify. This is just 4.07, and then this one could be written on the other side as BC cosine theta. If we sum of forces vertical equals to 0, then we get this is all positive. Okay, also this one positive. So you have here 6.79. We use this vertical, 4 over 5, and then the other one plus BC, okay, plus BC. What is this function? Sine theta, and then minus 8 equals to 0. This is just value of this one is 5.43, and then plus BC sine theta minus 8 equals to 0. So therefore we have BC sine theta 8 minus 5.43 minus 8 will give you negative 2.57 equals to 0. Or we could write BC sine theta is equal to 2.57. This one could also be like BC cosine theta is equal to 4.07. This is equation 1, let us say, and this one is equation 2. Okay, if we divide equation 1 and equation 2, divide equation 2. So copy this one, equation 1. You have BC, no, rather we use equation 2 divide equation 1 to make it tangent, okay? So equation 2, copy this one, sine theta over BC, equation 2, cosine theta, this one, is equal to the value BC sine theta is 2.57, and then the cosine theta is 4.07. BC and BC cancel out, so we have, go to the next, sine and cosine is tangent theta. Okay. Okay, we have actually sine theta and then cosine theta is equal to, what's that one? 2.57 divide 4.07 gives you 0.63. You know, 0.63. This is just tangent theta, okay, is equal to 0.63. Then you have theta is equal to inverse tangent negative 1 of 0.63. So theta could be calculated as inverse tangent of 0.63 will give you 32.2 degrees. Okay, that's 32.2 degrees. Now, once you have 32.2 degrees, we can compute BC. For example, we use this one, BC sine theta, BC sine of what is theta? This is 32.2 degrees. 32.2 degrees. Okay, I'll just trace this one. Okay, equals to, so that's BC sine theta 2.57. 2.57. Therefore, BC could be calculated as 4.82 kilonewton. Now let's proceed to this one, the last part. Now if you have already 4.82 BC, then we can compute also either of these, theta and BA. We need theta because we need to compute the height. Okay, here we sum up forces horizontal equals to 0. So we consider going to the right as positive. You have this one. 4.82. This is what function? Cosine 32.3. And then this one minus BA cosine theta equals to 0. Okay, this one could be simplified as 4.07 minus BA cosine theta. So we could rewrite BA cosine theta is equal to 4.07. Now summation forces vertical equals to 0. This part is positive. So this is BA as function, this is opposite sine theta. And then minus 4.82 sine of 32.3, and then this minus 3 going down equals to 0. So we can simplify this is BA sine theta. This is minus 4.82 times sine 32.3 is 2.58 minus 3 equals to 0. Or we could write BA sine theta going to the right. 2.58 minus 3, they're all negative, so that becomes 5.58. From negative will become positive. So we can say this is equation 1 and this is equation 2. Now I'll divide equation 2 by 1. BA sine theta, this is equation 2 from the previous slide. 5.58 is equal to 5.58 divided by BA cosine theta, this is equation 1, by this one, which is equal to 4.07. So can cancel. Sine and cosine is tangent theta, 5.08 or 58 all over 4.07. So theta could be calculated as 53.8. Okay, so how are we going to compute the h, which is unknown in the problem? Okay, where's h? So our h, see, if you have already this theta, this is theta, which is already we calculated. Theta is 53.8. Tangent of theta, which is 53.8, this one, this is 53.8, equals to h over adjacent, which is 2. So h will be equal to, so the value of h using your calculator, 2 meter times tangent 53.8 will give you 2.74 meters. Okay, take note that in our calculation, okay, we started from here, we get the value of d, and then we get c, joint c. That's why we have this joint c. And then once getting the value of theta, this angle BC, okay, 32.2, and then we calculated this BC 4.82. We can also just have it here 4.82, and at the same time the theta 32.3 is the same as theta BC. Okay, it's 32.3. We have this one, and then from here we can have another angle at BA, by which we did the calculation for that angle. Okay, and then from here we get the value of the h. So that's all for our tension cables with with tension forces, share this video and follow me.